Hello everyone, welcome to Helm of Science. So I hope that all of you are studying hard. So in this video, we will discuss a very important chapter of class 12 mathematics, and that is matrices. Okay, so without any further delays, let's get started. So matrices. Now matrices is actually the plural form of matrix. Okay, now what is matrix? That we have to understand. Matrix. Now, what is matrix? A collection of set of mn numbers, real or complex, arranged in the form of rectangular array having m rows that are horizontally arranged and n columns that are vertically arranged either under a pair of square brackets that is like this, or under a set of parentheses that is like this. Okay, so what is this saying? That a matrix, it is a collection. It's a very important word in this definition. It is a collection, not any value. So matrix is a collection of set of mn numbers, real or complex. That can be, it can be real or it can be imaginary number, which are arranged in the form of rectangular array having m rows that are horizontally arranged and n columns that are vertically arranged either under a pair of square brackets like this one or under a set of parentheses, this one. Now if we take an example, then how does it look like? Suppose I take pi 5 ei. Okay, now as you can see, this is a matrix, or this can be represented in another way. Okay, now this both represents matrix. Now you can see this is a collection of set of numbers which can be real or complex. See, there are real numbers as well, there are imaginary numbers as well. Okay, so this is a representation of a matrix that is under a square bracket or under a parenthesis. Okay, so this is a collection of set. Now it is saying that a collection of set of mn numbers. Now why mn numbers? Now you can see it is having m rows. Suppose here you can see in this matrix there are two rows, that is the horizontal ones. There are two rows. The horizontal ones are rows and the vertical ones are the columns. So here you can see that there are two rows and two columns. There are two rows and two columns are present, okay, in the matrix. So you can see that the number of elements present in this matrix is 2 into 2 equal to 4. Okay, so that is, it is saying that if a matrix have m rows that are horizontally arranged and n columns, then the number of elements that are present in that matrix, it is equal to mn. So it is saying that it is a collection of set of mn numbers. Okay, So here it is what? It is having two rows and two columns. So here number of elements is what? It is 4. Number of elements in the matrix is equal to 4. Okay, so they are arranged under a rectangular array. Okay, so they are under a set of square brackets or under a parenthesis. So here in this case there are two rows and two columns, so we are saying that number of elements in the matrix is 4. Okay, so now here we are saying that there are two rows and two columns. So for that we have a special term in matrix that is called order of a matrix. Now what is this order of a matrix? Try to understand. So here a matrix having m rows and n columns is called a matrix of order m into n. Okay, so this is the order of the matrix. Suppose a matrix is having m rows and n columns, then the matrix that will form will have an order m into n. So suppose in this case here you can say there are two rows. Suppose I take this as r1, this as r2, and this one as c1, and this one as c2. There are two rows and two columns. Okay, now here you can see two rows and two columns are present. Therefore the order of this matrix is 2 into 2 matrix. Here it is also 2 into 2 matrix. Now matrix can be represented in another way also, that is this one, that is here it is having 4 columns and 1 row. Okay, so you can see that 1 row is present and 4 columns are present. Okay, so the order of this matrix will be what? It will be 1 into 4, because here m is 1 and n is 4. Okay, similarly matrix can be represented like this also, that is we have 4 rows and 1 columns, that is this way. So here it is 4 rows and 1 column. You can see there are 4 rows and 1 column. Okay, so in that case the order of the matrix is 4 into 1. Okay, so I think it is clear. So order of a matrix is this one. Okay, now just now we have told that if a matrix has m rows and n columns, then the total number of elements in the matrix is mn numbers. Okay, so suppose an example is given. Suppose that a matrix has 18 elements. Okay, and we have to find out the possible order of the matrix. Of the matrix. So how we can find out? Just now we have told that suppose if a matrix has m rows and n columns, then the total number of elements in the matrix is mn. So here it is given that the matrix has 18 elements. So to find all possible order of the matrix with 18 elements, we will find all ordered pairs of natural numbers. Obviously this will be a natural number, whose product will be will be 18. Okay, so if the orders are like that their product is 18, then we are done. So here the possible orders can be possible orders, it will be 1, it will be 1 into 18, this can be a order. Again 18 into 1 can be a order. Okay, 2 into 9, this can be an order. 9 into 2, then we have 3 into 6, and then we have 6 into 3. So these are the possible orders of the matrix. See here, if this is the order, then their product is 18. Here also its product is 18. Here also, here also, here also, and here also. The product is 18. So these are the possible orders of the matrix that we can have. Okay. So I think it's clear. Now we come to the representation of a matrix. Representation of a matrix. Okay, so at first let's take an example that we have previously taken, that is pi 5 ei. Now here you can see that here this element, it is the intersection of the first row and the first column. If you can see carefully, this is the intersection of the first row and the first column. So here we write it in this way, that it is a11. So it is actually what? Intersection of first row and first column. We write it in this way. Okay, so here a11 is actually what? It is pi. Similarly, if we want to find a12, it is means what? A12 means it is the intersection of the first row and second column. That is, we have this 5. Okay, so it is 5. Now if we find a21, it is what? It will be E, because it is the intersection of the second row and first column. And if we find a22, it is I, it is the intersection of the second row and second column. Okay, so here we can say that if I have suppose aij, it is actually what? It is the intersection of ith row and jth column. Okay, so it's the intersection of ith row and jth column. Now the example that we have taken, it is a 2 by 2 matrix. Okay, so if we want to represent a matrix, so it is actually what? It is, we represent like this way: a equal to aij, the order is m into n, suppose, where I can vary from 1 to m and j can vary from 1 to n. Okay, so you can see that we represent a matrix like this way, that is a equal to aij m into n, where I can vary from 1 to n, that is I is the number of rows, that is it can vary from 1 to m, and j can vary from 1 to n. Okay, so I think it is clear. So in this way we represent a matrix. Okay, now we come to the equality of matrices. Equality of matrices. So what is it saying? Two matrices A and B are said to be equal when they have the same order and their corresponding elements are equal. That is, here both the condition has to be satisfied. That is, two matrices A and B are said to be equal when they have the same order. That is, the two matrices will have the same order and their corresponding elements are equal. Suppose we take an example. A, B, C, D is equal to, it is 1, 2, 3, 4. Okay, this way. Now, at first we have to check that whether they have same order or not. So this is a 2 by 2 matrix and this is also a 2 by 2 matrix. So they have same order. Now, if they are equal, then we can say that this A is equal to 1, B is equal to 2, C is equal to 3, and D is equal to 4. Why? Because if we consider this as a matrix A and this as a matrix B, so A is actually in the position A11, that is the intersection of the first row and the first column. Similarly, 1 is present in B11, so there are corresponding elements. Okay, so for the matrix to be equal, the corresponding elements must be equal. Okay, they have the same order already. So for the matrices to be equal, A11 will be equal to B11 then. So we can write A equal to 1. Similarly, B equal to 2. That means corresponding element of B is what? 2. Corresponding element of C is what? 3. And corresponding element of D is 4. Okay. So this is the concept of equality of matrices. That is, they will have same order and their corresponding elements will be equal. Okay. Now we come to the types of matrices or types of matrix. So the first one that we have, it is the row matrix. Now, what is row matrix? A matrix of order 1 into n is said to be a row matrix. That is what? That is the matrix has only one row and n number of columns. Okay, here n can be any natural number. Okay, so row matrix is saying that a matrix of order, it is 1 into n, is a row matrix. That is, the matrix has only one row. Let us take an example. Suppose we have an example that it is 3, 4, 6, 9. Okay, so here you can see that here number of rows is what? It is 1. The number of columns is 4. Okay, this is C1, this is C2, this is C3, and this is C4. But the row is actually what? Row is 1. So here order of the matrix is what? 1 into 4. So here n can be any natural number, no matter with that. But the m value, that is, or if the order is m into n, here m should be equal to 1 for row matrix. Okay, so for row matrix, number of rows is equal to 1. Okay, this is an example of row matrix. Now we come to column matrix, the second part. It is the column matrix. Now, what is column matrix all about? A matrix of order m into 1 is called a column matrix that is the matrix has only one column and m number of rows. Here m can be any natural number. Okay, so column matrix is saying that a matrix of order m into 1 is called a column matrix. That is, column matrix is a matrix which has only one column and m number of rows where m can be any natural number. Okay, so let us take an example. Suppose column matrix, I write it as 1, 2, 3. Okay, so it is what? It is having three rows, that is R1, R2, and R3, and this is one column, that is C1. So your order of the matrix is what? It is 1 into, sorry, it is 3 into 1. The order of the matrix is 3 into 1 as there are 3 rows and one column. So it is an example of column matrix. Okay. So for column matrix, number of column is 1. Okay. Now we come to the third part, that is the rectangular matrix. Now, what is this rectangular matrix? Rectangular matrix is a matrix of order m into n, where mn belongs to any natural number and m not equal to n. That means here number of rows not equal to number of columns. Then we will call it a rectangular matrix. That is a matrix of order m into n. Suppose a matrix is having with order m into n. Here m and n can be any natural number, but m should not be equal to n. That is, number of rows cannot be equal to number of columns. Then we will say that it is a rectangular matrix. Suppose we take an example, that is, we can write as 3 minus 5, 7, 4, 2, 9. Now see, here there are two rows, this one row and this one row, and there are three columns, this and this. So I'm writing that it is R1, this is R2. Now this is column 1, this is column 2, this is column 3. So here the order of the matrix is what? It is 2 into 3, since the number of rows is 2 and number of columns is 3. So it is 2 into 3 matrix. Now you can see that number of rows and columns is not equal. Number of rows is 2 and number of columns is 3. So here we will say that this is a rectangular matrix, since m and n, here m is what? 2 and n is what? 3. Now they are belonging to natural number and they are not equal, okay, to each other. That is, 2 is not equal to 3. So we will say that is a rectangular matrix. Okay. Now, important note that we will have, that is, when n is not equal to 1 for row matrix, then row matrix is a rectangular matrix. This is a very important thing, that for row matrix what we have, it is one row and number of columns can be any natural number. Now for this to be rectangular matrix, that is for the row matrix to be rectangular matrix, n should not be equal to 1, then it will be 1 into 1, then number of rows will be number of columns. So it is not the case for rectangular matrix. So the row matrix to be rectangular matrix, n should be not equal to 1. Okay, it can be any other value except 1. Okay, so then we will say that a row matrix is also an example of rectangular matrix. Also we can say that when m is not equal to 1 for column matrix, then column matrix is also a rectangular matrix. Okay, so I think this is also clear. That means for column matrix we have m rows and one column. Now here, if m is equal to 1, then it will be 1 into 1 matrix. Then it will not be a rectangular matrix because number of columns will be equal to number of rows. So m can be any natural number except 1 for the column matrix to be rectangular matrix. Okay, so I think it is clear. Now we come to the fourth type of the matrix, that is the square matrix. Square matrix. Now what is this all about? A matrix A equal to Aij m into n, that is, it is a matrix Aij whose order is m into n, or you can say m by n, is called a square matrix when m equal to n for m and n belongs to natural number. Okay, that is, for square matrix, number of rows equal to number of columns. Okay, so it's just the opposite case of rectangular matrix. That is, in rectangular matrix m is not equal to n, and in square matrix m is equal to n. So here number of rows is equal to number of columns. So let's take an example. Suppose alpha, beta, gamma and delta. Okay, so you can see here that there are two rows. This alpha, beta, this is on one row, and gamma, delta, it is one row, and there are two columns as well, that is alpha, gamma and beta, delta. So here it is r1 and this is r2, this is column 1, this is column 2. So it is what? It is a 2 by 2 matrix. So you can see that here number of rows is also 2 and number of columns is also 2. So here it is a 2 by 2 matrix. That is, here m is equal to n. Okay, and m and n are all belonging to natural number. So here m is equal to n. That means number of rows is equal to number of columns. So this is an example of square matrix. Okay. Now in square matrix we have important thing. Now square matrix can be of order 3 by 3. Now that looks like we can write this one as 9 8 0 4 2 7. Suppose in an example 5 0 2. Now this is a square matrix of order 3 by 3. Why? You can see that here there are three rows, this one row, this one row, and this is one row, and there are also three columns, this one, and this one. Okay, so this is what? This is row 1, This is row 2, and the last one is row 3. And this one is what? It's column 1, this is column 2, and this is column 3. So what? There are 3 rows and 3 columns. So number of rows is equal to number of columns. So it is a 3 by 3 matrix, and it is a square matrix. Now in square matrix, we have an important thing, that what is the leading diagonal? Leading diagonal or it is called principal diagonal. Now what is this all about? So it is actually, it is a diagonal which starts at the top of the leftmost column and ends at the bottom of the rightmost column. Okay, so leading diagonal or principal diagonal, it is the diagonal which starts at the top of the leftmost column and ends at the bottom of the rightmost column. That means what? That means it is starting from the top of the leftmost column, that is this point, and it is ending at the point that is ending at the bottom of the rightmost column, that is ending at this point. So how does it look like? This is look like, this will look like this one. So this is the leading diagonal of a square matrix. Okay, so this one is called the leading diagonal. Now you can see that this is what? This is the element A11. Now this two element, actually it is what? It is the intersection of the second row and second column. So it is actually what? It is A22, and this 2 is actually what? It is A33, that is the intersection of the third row and the third column. So you can see that here A11, A22, A33, these are the elements of the leading diagonal. Okay, so you can write this one as that for matrix A equal to Aij m by n is a square matrix okay, then the elements A11, A22, A33 up to AMN, that is Aij when I equal to j, that is when number of row, that is ith row will be equal to jth column, that is I equal to j, that is 1 1, that is A11, A22, A33, A44, like this. Okay, are said to be, or are said to constitute the leading diagonal or principal diagonal. That is what it is saying. That is the elements which are like that Aij when I equal to j, that means A11, A22, A23, or sorry, A11, A22, A33, A44, like this. These elements will constitute the leading diagonal or the principal diagonal. Okay, suppose in this case here it is A11, A22, and A33. These are constituting the leading diagonal. Okay, so here in this case also, here is 2 by 2 matrix. The leading diagonal is this one. It is the element containing alpha and delta. Now you can see that alpha is actually here what, a11, that is intersection of the first row and the first column, and this delta is actually what, a22, that is the intersection of the second row and second column. So you can see that a11 a22 is constituting the leading diagonal. Okay, so next we come to another important thing related to leading diagonal, that is the trace of square matrix. Trace of square matrix. Suppose a square matrix is, suppose I denote it as A, that is Aij, that is suppose m into m. Here it is, since number of rows is equal to number of columns, so I have written m into m. Okay, so trace of A is actually what? You can write this one, that sum of all elements in the leading diagonal sum of all the elements in the leading diagonal of a square matrix is called trace of a square matrix. That is what, trace of a square matrix is the sum of all the elements that are present in the leading diagonal, or they are constituting the leading diagonal. That means the sum of the elements which are present in the positions like a11, a22, a33, like that. Okay, so here in this case, the example that I have taken, in this case, if I suppose mark is this one as a equal to this one, so here trace of A will be what? Trace of A will be sum of all the elements in the leading diagonal. Now what are the elements? It is 9, 2 and 2, that is 9 plus 2 plus 2. Now this is what, 9 plus 4, that is 13. Okay, so I think it is clear. Okay, so you can generalize this, that you can write trace of square matrix is equal to what? All the diagonal elements. That is all the leading diagonal elements, that is a11 plus a22, their summation of all the leading diagonal elements up to a in m. Okay, if the order is n, or you can write m into m also, depending on the order of the matrix. Okay, now we come to the next part, that is the diagonal matrix. Now diagonal matrix is part of the square matrix. That means diagonal matrix is a square matrix. Now what is the speciality of this matrix? Write it down. A square matrix of, or you can say a square matrix is said to be a diagonal matrix if all of its non-diagonal elements are 0, but the diagonal elements are not all 0. Okay, so in generalization, what we can write, that A is equal to Aij m into n, where m equal to n, n belongs to natural number. Okay, and aij is equal to 0 when I not equal to j. That is, when the leading diagonals is coming, the elements can be 0. That means all the elements cannot be 0. You can say if it is a 3 by 3 matrix, 3 by 3 order matrix, then the diagonal elements should have at least 2 0. Not all can be 3 0. That means in diagonal matrix all the elements except the diagonal elements are 0, but in diagonal elements all the diagonal elements can be different. All the diagonal elements cannot be 0, but two of the diagonal elements, if it is a 3 by 3 matrix, then number of zeros in the diagonal elements can be 2, but it cannot be 3. Suppose in a 2 by 2 diagonal matrix, number of zeros in the diagonal matrix can be 1, but it cannot be 2. Okay, so this is a very important thing, that the diagonal elements are not all 0. This one is very important line, but the non-diagonal elements are all 0. Suppose we take an example to understand it in a better way. So example, suppose I have taken that it is -1 0 0 0 2 0 0 0 3. Now you can see that this 0, that means the elements which are 0, these are not the diagonal elements. The diagonal elements are what? This one is are the diagonal elements. Now all the others are non-diagonal elements. So according to definition, it is what? All the non-diagonal elements are 0, but the diagonal elements are not all 0. That means what? It can be 0, but it cannot be all the diagonal elements that are 0. It can be happen that diagonal elements are 0, but it is one less than from the numbers. That means one less than from the element present in the diagonals. Okay, that is another example that we can take here. This is also a diagonal matrix, that is that all the diagonal elements are different, but that is all diagonal elements are not 0. Now this can be another example. Suppose is -1 0 0 0 0 0 0 0. Now you can see here all the elements are 0 except this one. That is, here the diagonal elements are what? This one. These are the diagonal elements. These are the diagonal elements. Now among these three diagonal elements, two of them can be 0, but this -1 cannot be 0. Cannot be 0. If this is 0, then it will have another name. We will discuss in the next class. So diagonal matrix, this one is also the diagonal matrix. That is, all the diagonal elements can be different, or it may happen that the elements in the leading diagonal can be 0, but all the diagonal elements will not be 0. Okay, so I think it is clear about the concept of diagonal matrix. Now diagonal matrix can be represented another way. That is the example that I have written. This can be written like this, that diaj of -1 2 3. That is, in the diagonal elements -1 2 3 are present, so we write in this way. This can be written as -1 0 0. Okay, these are the diagonal matrix. Okay, so I think it is clear about the concept. So this was a introductory portion of the matrix. So a few topics are left to be done. Some properties are left, some other definitions are left to be done. So we will do this remaining portions in the next class. So I hope that all of you have liked the video, and if you did, please like the video and share it among your friends, and subscribe to our channel Helm of Science for more of such videos. Okay, so until then, keep studying hard. Thank you so much for watching.